Hi, this is Yvonne Gabriel, your AP Environmental Science teacher at the Science and Mathematics Academy at Aberdeen High School in Harford County, Maryland. We're going to go through the steps in doing as well as you can on an EnergyFRQ for the AP Environmental Science exam. I highly recommend, because of the pace I'm going to go through this video, that you get paper and pencil and you work through everything in advance and push pause regularly on this video. Before you push pause, there are a few units that you're going to need to know for the first set of problems, such as the ones listed here. Please look through them very quickly and record what you need to use or you haven't recalled on your own. I will read through the scenario one time for you just so that you get the pronunciations correct, but please take your time and read it again on your own. Smallville is a community with a population of 8,000 homes. It gets its electricity from a small municipal coal-burning power plant just outside of town. The power plant's capacity is rated at 20 megawatts, with the average home consuming 10,000 kilowatt hours of electricity per year. Residents of Smallville pay the utility 12 cents per kilowatt hour. A group of entrepreneurs is suggesting that the residents support a measure to install 10 wind turbines on existing farmland. Each wind turbine is capable of producing 1.5 megawatts of electricity. The cost per wind turbine is $2.5 million to purchase and operate for 20 years. The existing power plant runs 8,000 hours per year. How many kilowatt hours of electricity is the current plant capable of producing? This is the first problem we're going to try and solve together right now. Please try and push pause and try and solve this on your own paper. Then push play again. Remember that we're trying to get to kilowatt hours per year, but we haven't been given kilowatt hours for the plant. All we've been given is that the plant's capacity is rated at 20 megawatts. So we're going to set up our first factor, which is 20 megawatts over 1. We want to cancel out megawatts, and since we want to cancel it out, we should set up our second factor so that we can do that. Your second factor should look like 1 times 10 to the 6 watts, which is equal to 1 megawatt. 10 to the 6 means 6 zeros after the point, the decimal point. Now we can cancel out our units. So if we cancel out the megawatts over here with over here, what we have left in units is just watts. But remember, we want to work our way towards kilowatt hours per year. So the next logical step it would be to go from watts to kilowatts. Kilowatts is equal to 1,000 watts. 1,000 is the same as 1.0 times 10 to the third watts. But we want to put this on the bottom because we want to cancel it out. We can only cancel them out if one's on the top and one's on the bottom, in the numerator position and the denominator position. So once we put 1 kilowatt is equal to 1,000 watts, then we can cancel out our watts, cancel out our watts. That still leaves all our values. We have to multiply 20 times 1 million times 1, and then divide that by 1 times 1,000, which gives us 2.0 times 10 to the 4th kilowatts. Now our next step is to convert our kilowatts into kilowatt hours per year. So the next thing you set up is what you just ended with in this first conversion. So we put our answer right up here, and we're in kilowatts. We want to work our way towards kilowatt hours per year, so we don't really need to cancel out our kilowatts. We just want to multiply something for the hours. We've been given that the plant operates at 8,000 hours per year, so we put that factor in. 8,000 hours per year. We actually want to keep all these units. We want to know, in order to solve this first part of the problem for part A, kilowatt hours per year. So if we multiply this number by this number, we come up with 16,000 times 10 to the 4th kilowatt hours per year. But oh, no. This is not how you should finally write your final answer. You should write it in correct scientific notation. And you all could have done this a little differently than I did. This is just one way that a student may have thought through this problem. So the actual answer is 1.6 times 10 to the 8th kilowatt hours per year. Now on your paper, please take note of what we're trying to solve for part B and any information that you need from the scenario. How many kilowatt hours of electricity do the residents of Smallville consume in 1 year? So take a look at this. Take a look at the question again, write down what you know, and write down what you need to know. Try to solve the problem and then push record again. Play. Push play again. So things that you already know in order to find out what the residents of Smallville consume in 1 year are that there are 8,000 homes and that the average home consumes 10,000 kilowatt hours of electricity per year. So we just set up our values and we start with our 8,000 homes, which is the same as 8 times 10 to the third homes over 1. And we find out our kilowatt hours per home is right up here, 10,000 kilowatt hours, which gives us 8 times 10 to the 7th kilowatt hours per year. For the last part of this EnergyFRQ, they're asking you to compare the answers that you came up with for A and B. You have to compare them. If you have to compare them, you need to be talking about the numbers and what they mean, and then you have to draw conclusions about them. So please pause this and then check your answer on the next screen when you're ready. Now, you really have to elaborate. This is just one way that you could have written it. I'm not going to read this to you because I don't want our recording to take up any more space. Read this, pause it before the slide changes. Notice that the information in the paragraph really pulls from the rest of this scenario. So they asked you another question. They wanted you to compare your answers for A and B, but they really were looking for, were you able to connect to all the possibilities with the scenario given? And that's why all of this information is recorded here. You're really showing that you really know your content as well as knowing the math. Now there's a few more questions that can come along with this FRQ, which I'm going to show you the examples of in a minute. So part D and E are more questions to show that you're an expert in the computation and in the content. Please read and try to work through them before you go to the next slide. Now when you set up your answers to your FRQs, it's very important that the reader who is scoring your work knows exactly where you got your numbers from, what you want your final answer to be, but they're also looking at your work. So when I tried to solve this problem, I made sure that the reader would know that my starting number came from part B, which is why this is in red. So first we want to find out the kilowatt hours for 20 years. So we just take our answer from part B per year, and then we're looking at 20 years in this question, which gives us 1.6 times 10 to the 9th kilowatt hours. But we don't want kilowatt hours. This was asking us to find out the cost in kilowatt hours. So we also have to find out the direct cost. It's easiest to start with for 20 years. This is how I did it. You could have done it a little differently. This is just another way. So for 10 turbines, knowing that it costs this much money per turbine, we just calculate, and I'm trying to fit everything I can on my screen, so sorry if my scientific notation's getting a little sloppy. I just wanted you to be able to see it. And then that's still not enough because this is giving us our total cost for 20 years. So we've worked our way to kilowatt hours, to 20 years. Now we want to know how much it cost per kilowatt hour. So cost per kilowatt hour, and that is my final answer. If you did not get this answer, figure out what I did compared to what you did and see where you went wrong. The last question on this FRQ asks for the pros and cons of the existing coal-burning plant compared with the proposed wind farm. So you should come up with a table of pros and cons. Pause, and then when you're ready, check your answer. I have 7 pros and cons. For the sake of this recording and conserving space, please note that I am going to go to the next screen in a few seconds. So they did a little more calculations here. They showed you that they're showing the reader that they really know how to break down all the information that was given mathematically. And in all these other examples, we're showing you, the writer is showing you that they really know their content. And there's the other examples there. And this is where this information was taken from. If you have any questions, please feel free to email me. Good luck on your next exam.